All right, so going through this paper, guys, the biggest section of this test, one of the biggest sections, there's two actually huge sections. One of them is being familiar with median, angle bisector, perpendicular bisector, altitudes, all that stuff, the points of concurrency, and what those mean, okay? So I'm not going to answer this. You guys have plenty of notes on it, and we've been doing it long enough. You should know all of this stuff, okay? If you don't, yes?
When an angle bisector, when it hits the other side, does it hit the midpoint?
So an angle bisector does not necessarily hit the midpoint. There's only one thing it does. It bisects. If this was an angle bisector, it bisects the angle. That's all it does. It could hit the other end's midpoint. Okay? It could hit the other side's midpoint, but it doesn't necessarily. Okay? All right. Let's just actually go through it this way. I'm gonna list them out. Hey, I don't want you guys talking while I'm doing this. All right? So I'm gonna just list them out straight through. So let's start with median. Okay, so let's go new page. All right. A median. Okay, so it goes from a vertex. So just drawing a junky triangle. I almost said that. All right. So a median, it just goes from one end's vertex to the opposite end's midpoint. That's all it does, okay? When you have three medians that join together, the point of concurrency is called a centroid. And what you need to remember about a centroid is that the distance from the vertex to the centroid is 2/3 of the way all the way across to the other end. So for example, if this entire median was, say, 12 long, from here to here is 12 long, that means this is 4, and that is 4. Okay? That's the idea of medians and centroids. Okay, so we've done median. I'll put a reminder up here. Okay, median. Okay, so medians. Then there's also, let's go angle bisector. Angle bisector. All right, what an angle bisector does is it just simply cuts the angle in half. Nothing more, okay?
Right in the middle?
Right in the middle of the angle. It's an angle, and it's bisecting it, all right?
Your median, does it have to be a vertex?
Huh?
Does it have to be in a vertex?
Does it have to be in a vertex? Yeah, because that's where the angle is, and it bisects the angle, right? So all it does is it bisects the angle. It could hit at the midpoint on the other side. It doesn't have to, all right? So the length of this part isn't not necessarily equal to the length of that part, but it's an angle bisector. It bisects the angle. That's all it does, okay? So angle bisector, and when you have all three angle bisectors join together, all three angle bisectors, when they join together, they intersect at what's called an incenter. So incenter. And what's special about the incenter is that the distance from the incenter, so from here to any of the sides, so from here to here to here, or from here to here, they're all the same distance. That's what's special about an incenter.
So on the median, it doesn't have to start from
The median starts from the vertex and it goes to the opposite end's midpoint. All right, perpendicular bisector. Perpendicular bisector. It just bisects a side. So it bisects a side at a 90-degree angle. So that has to be 90 degrees. And by bisect, I mean this side needs to equal that side. Okay, the next one, the angle bisector or perpendicular bisector here would bisect this side, again at a 90-degree angle. This part right here would have to equal this part. And then the last one, I guess would probably be right about here. It bisects this side, again, 90-degree angle. So this side equals this side. And the point where all three angle bisectors, all three perpendicular bisectors come together, that's called the circumcenter. And the distance from the circumcenter, this point, to all the vertices should be the exact same. Okay, that's the special property with circumcenters. The altitudes, there's nothing real special about those. You just need to be able to make sure you can create an altitude for all the circumstances. So I'm going to just draw all three altitudes for this triangle. It's kind of tough to visualize. I'm actually going to, let's do a simple triangle also, something like that. Okay, so an altitude for a more simple triangle, it just goes from a vertex to the opposite end side, straight down, hits at a 90-degree angle. That's what an altitude does. Now, this black triangle that I drew up here, this one's a little bit more difficult to draw an altitude for because it goes from its vertex straight down like this, but there is no base to hit there, okay? So if you just extend the base, imagine the base being extended out here. That's the 90-degree angle happening right there, okay? So altitudes, and all three altitudes, if you draw them all out, they all intersect at one point also. And when the altitudes intersect, they intersect at what is called an orthocenter. Okay, that's all the stuff I'm going to explain for that. There's a lot of problems involving those types of questions, all right? And if you want to write on your note cards all those definitions, that's going to take up a lot of space, but it might be the most helpful thing for you, okay? All right, so going on, and again, I'm going to post this video online if you want to write your card out however you want. I'm just going to make sure I go over every single thing. I think I'm going to try to go over every single thing on here. Okay, so this whole first page, let's see. That's all about what we just talked about. That's what we just talked about. That is what we just talked about, angle bisector. That's what we just talked about. Name the longest side of ABC. Okay, so to find the longest side, if you have a triangle and it gives you all the angles, the longest side is going to be the side that's created by the largest angle. So for example, this angle 70 right here is taking two sides and it's opening them up 70 degrees. That's going to be the longest side that it creates. So this side right here, side BC, that's the longest side. Okay? It's the side that's across from the biggest angle. Name the angle with the greatest measure. Okay, it's the same idea except reverse. The angle with the greatest measure is going to be the angle that creates the longest side. In this case, that's the longest side, so the largest angle is this one right here, okay, across from it. So, angle I. What is the relationship between the lengths of DG and GF? Okay, so this is called the Hinge Theorem. The idea is that you have two sides bordering an angle, okay? You have a 30-degree angle, but you have this 8-inch side, let's say 8-inch side, and then you've got some other side, and this 30-degree angle opens up those sides, and it creates a third side over here, okay? It opens up those sides, and it opens them up by 30 degrees. Now, if you take the same exact two sides, which here's the 8-inch side, and here's that other side again, and you open them up, but you only open them up 20 degrees, right? Then you would think that the distance that this side is, because it's only opened up 20 degrees, is going to be smaller than the distance that this side is. Does that make sense? That's the idea behind it, okay? So, in other words, you know that DG, the distance that DG is greater than the distance that FG is. And that's all you know. You know DG is greater than GF, or FG. All right, going on. Let's see, what is the relationship between the measures of angle 1 and angle 2? So it's the same idea. You see that this side is the same as that side, and you see that they share this side. So you have these angles that are opening these two sides up. Angle 1 is opening these two sides up. And when it opens it up, it creates a line that is 12 inches. Let's go with inches again, 12 inches long. When angle 2 opens the same two lines up, it creates a line or a side that is 11 inches long, okay? So that means angle 1 has to be opening up more than angle 2. So that means angle 1 has to be greater than, and I talked about this, like all these signs, they get so mixed up looking. But angle 1 is greater than angle 2. Because angle 1 is the angle that's creating the bigger side. All right? And again, that just makes complete sense. It really does. If you guys watch the video, if you don't understand it right now, you go back and you watch it, it'll make complete sense. Just make sure you're staying logical about it all. All right. Which line segment is the longest? Well, we know how many degrees are in a triangle. 180 degrees, okay? So you got 120 plus 30, that's 150, so that means this has to be 30. 28 plus 123, that's 140, 151. So this, I do believe, is 29. I hope I did that right. If I didn't, first person to correct me based on the video, or maybe even today, I'll give you some extra credit. So let's see. Which line segment is the longest? The one that's across from the biggest angle. That's the biggest angle. Longest segment goes from P to S. There's the longest segment. Which line segment is the shortest? It's going to be across from the shortest angle. 28. 28, okay, so P to Q is the shortest. Okay, the measures of two sides of ABC are 5 and 12. So what that's saying is or 22. So you've got this triangle with a side length of 5 and 22. The question is, how long, what are the different measurements that side could be in order to actually make it a triangle? That's what the question is, okay? And I talked about how if you want the biggest that it could possibly be, you take both of these sides and you actually add them together. Because imagine if you have a 22-inch side and then a 5-inch side that's completely open like this. That means this red side, if that 5-inch side is actually like this, the red side needs to be 27 inches, right? At most. So 27. So it needs to be at least 27 inches in case that side of 5 is actually open, okay? Now, say the side of 5 is actually totally closed. Then you need the difference between the two. 22 minus 5, okay? And that's 17. So that side needs to be bigger than 17, but smaller than 27 in order to make a triangle. And again, it really does. It makes complete sense. This is called, guys, well, hold on. That's called the triangle inequality theorem. I kind of want to go back to this idea right here. I need to actually articulate what this is called. It's called the Hinge theorem. Do you know what a hinge does? What's a hinge? Like a door hinge. Yeah, a door hinge. It swings open like this. That's what a hinge does, right? So what's happening is you have a side length and a side length. Those side lengths are all the same, right? And you have the hinge, the angle that's swinging those sides open, right? And the question is, which is the biggest angle, bigger angle to create the bigger side? Angle 1 is bigger because it creates a bigger side. It's a hinge theorem. Does that make sense? You have two sides that are the same length being swung open by an angle. It's a hinge theorem, all right? That's called the Hinge theorem. You're going to want to write that down somewhere. All right, I think that was all on this page. Nope, okay. Point P is the circumcenter. Well, we already talked about this a little bit. I put it down on the notes, but let's just do it real quick. If that's a circumcenter, then circumcenter is the point where all three perpendicular bisectors join together, right? Which means it's the same distance to all of the vertices, like that. So it says list any segment, congruent segment to each segment. Okay, so BT. B to T. What is congruent with B to T? Well, these are perpendicular bisectors. That means this has to be the same as that right there. So T to C. So that's congruent with T to C. And again, guys, the reason I know that is because it's a perpendicular bisector. It's bisecting this side. It's cutting it in half. All right? How many of you, just a quick question, how many of you would be tempted, honestly, how many of you would honestly be tempted to put BR? I was so tempted to do that just now, okay? But you can't. That's not necessarily true. What do we know? We know that these are perpendicular bisectors, which means that this is bisecting this side. BC is being bisected by that TP line, all right? TP. That could be Tony Parker or that could be toilet paper. I don't know. All right. AP. Which one's the same as AP? PC, PB, right? PB, peanut butter. PC, anybody have a good thing for PC? Oh, personal computer? All right. All right. AS, from there to there. Which one's the same as AS? SC. How do you know that? Because it looks like it?
No, because
Because it's a perpendicular bisector. That is bisecting, so this is the same as that. So that's congruent with SC. All right, moving on. Let's see. Centroid. Huh?
That's wrong.
What is? What is?
UJ. You put it on NU.
UJ.
It's 3 and you put it on NU.
Okay. Well, let's just see if we can answer them based on that. Yeah, you're probably right though. You're probably right. Here, I'm gonna let's go with what Claire says. I think she's right. It's not necessarily true, but let's go with that. I think that was supposed to be right here. No. No.
Yes, because EM equals 27.
EM.
Equals 27, so it has to be 9.
So it all just got mixed up, huh? Yeah, it did. Well, that's quite unfortunate. Here we go. So let's put that there. I'm glad you caught that. Okay, so let's go ahead and answer one of these just in case. So with the new listings of all this stuff, and let's make sure this one's right. So K to U is 12, does it? Yeah, okay. So find the measurements of each of one of these. I'm just going to work down the odds. Let's do that. So C to U. Okay, so this is a centroid. That means it's cut into thirds. If that's 12, then this is 12 and that's 12. 12, 12. So from C to U, that's 24. Okay, 24. Now let's go back on that. Uh-oh. There we go. All right, C to K, all the way across. Okay, so if that's 24, 12 more, that's going to be 36. And E to U is from here to here. And we know that M to U is 9. So we know that this is going to be 9 and that's going to be 9. So that should be 18. All right, going on. Compare the given measures. All right, this is important stuff for the test. This is another one of the really big concepts right here. Compare the given measures. It's dealing with the Hinge theorem. The Hinge theorem's all over this thing. So it says MR, so is this one, how does the measure between M and R to P compare? MR needs to be greater than, because the angle that's creating MR, using the exact same two sides, is greater than the angle that's creating RP. So MR needs to be bigger than RP. Same idea here. Well, I'm not going to go through all these and answer all of them. That's the same concept. So this is an important one. All right, you guys are going to need to know to do this, how to do this. It's pretty difficult, but it's the same idea. All right, so the idea is that the two sides that are being shared right now, this side and this side are equal, right? And this side. So the angle that is creating 4x minus 10, this 120 is creating 4x minus 10, so 4x minus 10, how would it compare to this side right here, which is being made by 115? This needs to be greater than 40. And then from there, you would have to solve it out. So you would add 10 to the other side, so you have 4x greater than 50 divided by 4 greater than 12.5, like that. So x, if that's going to be true, then x has to be greater than 12.5. That's what that's saying. All right, so going on. I'm pretty sure this is all stuff that's just similar to what we were just doing. Let's see. Yeah, that's actually the exact same problem that we just did. So let's skip all this. Same idea. Compare the given measures. I still think this is the same idea, but I'll just work one out with you. So it says measure of angle STR. So STR. So it's talking about that. How does that compare with TRU? TRU. How does that compare with this? Yeah, STR is greater because it's making a greater side. Okay? So STR, the measure of angle STR, is greater than the measure of angle URT, or what is it? TRU. True. Okay. List the angles of ABC from smallest to largest. Guys, this is actually really easy, but it doesn't give you a picture. So you need to draw the picture. That's it. It really is actually very easy. So it says A to B. Let's call that A. Let's call that B. From A to B, that's 17. Okay. From B to C, let's call that B to C. That's point C. That is B to C is 21. Okay. And then from A to C, all right, so the remaining part, that's A to C right there, that's 18. So what's the biggest? Well, from smallest to largest. Okay, so what's the smallest angle? It's across from 17, so it's angle C. Angle C. Next smallest angle, B. It's across from 18. And then the largest angle is across from 21, the biggest side. Angle A. Okay, list the sides of ABC from longest to shortest. So this is kind of the same idea. You have this triangle. Let's just do the middle one. You have a triangle. I don't know if the triangle is actually going to look like this at all. It doesn't really matter. So I'm going to call this C. Let's call this B. Let's call this A. All right, so it says that C is 101. 101. It says that B is 70. So if that's 101 and that's 70, then what's A? It's actually just 9, right? That's 9. Now you need to do that in order to list the sides from longest to shortest. Does this make sense so far, though? Do you see how this triangle looks nothing like that being 101 degrees? But it doesn't matter. It's actually using the logic that matters. 1 second, sir. 1 second. All right. So longest to shortest. The longest side is going to be side BA. BA is the longest. BA. And then CA, second longest, and then the shortest side is going to be across from A. Alex, what was your question, man? How to get 9? 101 plus 70 plus 9 is 180 degrees for the triangle. Yeah, that's B.
No.
CB, yeah. Sorry. That's B. Okay. All right. List the sides in order. Okay, same concept. You guys are good on that. Going on. This important stuff. I will say you'll have a test question very similar to this, except at least it's going to draw the picture. But the idea, guys, is draw a triangle. Here it is. Well, I'm going to need a bigger triangle. Okay, there's my triangle. Angle A. Let's call this one angle A. That's 9x plus 29. Angle B. All right, this is angle B. That's going to be 93 minus 5x. I'm going to actually have to solve this one out because this one is not the easiest. Angle C is 10x plus 2. Everybody's good so far? So far, so good? To actually solve this, what's the first thing I'm going to have to do? All of them added together equals 180. Exactly. Okay? So we need to, I'm going to just write over the top of this. So we need to take 9x plus 29 plus 10x plus 2 plus 93 minus 5x. All that equals 180. I'm going to begin. That might be kind of intimidating to some of you, but it's actually really easy. First thing you do, combine all your like terms. In other words, 9x, 10x, negative 5x, combine them all. So you got 5x, that's 14 x's. 14 x's. Combine all these. 29, 2, 93. So that's 95, that's 115, 124. Again, if I do something wrong on this, I apologize. You can just let me know. I'll figure it out. Okay. I just combined all like terms. From here, it's easy. Okay? From here, it's easy. Subtract 124. So I have 14x equals 56. Divide by 14. Anybody know? 4. Yep, x equals 4. And because I got something solid, my confidence goes up just a little bit. Feeling good. I think I did all that right. All right. And then it says find the measure, find the angle measures first, then decide which sides are longest. So from here, you would actually have to go back and take that x plus 4, or x equals 4, and plug it into each one of these to find out what are the actual angle measures, right? So you could find out, okay, but based on that, which sides are the longest. Okay? Multiple step problem. All right. Any questions on that? Okay.
How'd you do that whole thing, sir?
Huh?
How'd you do the whole thing?
What whole thing?
The whole problem.
No, sir. You're going to have to go back and watch the video, senor. All right. Senor. Okay. Triangle inequality theorem. This is something that we've already worked a few times, but it's the idea that the third side... Okay, well, when you're given three sides, if it's possible to make a triangle out of this, the sum of the two smallest sides has to exceed the third side, right? So that means, in this case, the two smaller sides, 3 plus 2, it has to be bigger than 6. Is that true? Is 3 plus 2 bigger than 6? No. So it's not a triangle. Okay, that one can never be a triangle. Is 4 plus 5 bigger than 7? Yeah, that is a triangle. That's the idea. You take the two smaller sides, add them together, make sure it is bigger than the third side, and if it is, then you can make a triangle out of it. For example, I'm looking for one where I'm going to take the two smaller sides, add them together, and actually get the third side. If I don't see one, I'm going to make one. I don't see one. Okay, so I'm going to make one. What if I had 1, 3, and 4? Does that make a triangle? Is 1 plus 3 bigger than 4? No. That does not make a triangle. It's not bigger. It's equal to. Sure, go for it. All right. Last little bit. The idea is so you're trying to find this is a big concept, by the way. You're gonna be asked this question in 3 different ways probably on the test. Find the range of possible measures for the third side. So if you have 9 and 5, I'm not going to rewrite it. So if you have 9 and 5, the possibilities, right, for that third side is you can do 9 plus 5. So if you have the 9 and 5, so what I'm doing with my hands right now is if you have a 9-foot side and a 5-foot side, okay, the possibilities for this third side could be 9 and 5 added together, right, like this. So if you swing this out like a hinge, right, 9 and 5 added is 14. So x could be anything smaller than 14, but x also has to be anything bigger than if you take 9 and you subtract the 5. So it actually swings in this way. 9 minus 5 is 4. So x has to be anything bigger than 4, but smaller than 14. And I do believe, thank goodness, that is it.